Welcome back to the class on dynamics. As far as the last time, the previous class was concerned, in the previous class we have been talking about the concepts of the relative velocity analysis of the rigid body. And in the previous class we have derived that if we have any rigid body, and this rigid body is undergoing the planar motion, okay, it has two-dimensional motion. For any 2 points A and B of the rigid body, for any 2 points of the rigid body with respect to some coordinate system, with respect to some XY coordinate system, we have the relationship between the velocity of point B with respect to the velocity of point A, okay? And we have said that, in fact, we have derived that velocity of point B is equal to the velocity of point A, is equal to the velocity of point A, plus the cross product between the angular velocity of the vector joining point A with point B, okay, with cross product with the radius vector from A to B, that is RAB. This is what we derived last time. And this equation was very important equation for us in the sense that we realized that the velocity of 2 points of the body undergoing planar motion, the velocities are not same, the velocities are different. Okay, and the velocities are different because the body in planar motion has some angular velocity. As long as the body in planar motion has angular velocity, till then the velocity of the 2 points will be different. But if the body is moving in such a way, it's translating, okay? Translation motion is the motion wherein the angular velocity of the body is 0. The body does not have any component of angular velocity, so at that time the velocity of any 2 points is same. Let's again, today we try to consolidate on this equation and try to solve a few more questions. We have the question as is given here. The link shown in the figure is guided by 2 blocks A and B, which move in the fixed slots. If the velocity of A is 2 meters per second downwards, determine the velocity of B at the instant theta is equal to 45 dt. In fact, we have solved these types of questions last time. We are given that we have a mechanism, and this mechanism is composed of a link between point A and point B. And as far as the link A is concerned, the link A happens to be a slider, which is sliding, which is in sliding. Okay, as far as link B is concerned, link B is also sliding. Okay, so as far as this, so link A is sliding, link B is also sliding. The dimensions are given to us. Now the point A is moving down with velocity 2 meters per second. We have to find out the velocity of point B. First of all, the concept is we should be drawing the coordinate system. As far as the coordinate system is concerned, the coordinate system is, first off, let's select this to be our origin. Let's say this is our origin, and this we treat as our x-axis. And let's treat this to be our y-axis. Let's say this is our y-axis. So we treat this to be our x-axis. We treat this to be our y-axis. Okay, it's like this. And this is our origin. Okay, now we have 2 points. We have point A, we have point B. We have to find the velocity of point B. So let's draw the vectors. The drawing vectors will be from O to A. And then we draw a vector from A to B. And we also draw a vector from O to B. Sorry. We also draw a vector from O to B. It's like, okay. So if you apply the triangle law of vectors, we can simply write that velocity of point B, this is what we have been doing. This is from the previous case. We draw the radius vector from the origin to point O. From point O, we draw the radius vector to point B. Okay. Then you also draw the radius vector from point A to point B. And we can write velocity of point B is equal to velocity of point A. Okay, this is how we do it. Similarly, since we have drawn the radius vector from point A to point B, we can simply write velocity of point B is equal to velocity of point A is equal to velocity of point A plus angular velocity of AB, cross the radius vector between A and B. We'll write this as RAB vector. This is how we write it. Okay, cross RAB vector. Now it's very important here to realize one more thing. We know velocity of point B. If I rub all these, as far as the velocity of point B is concerned, we can easily understand and realize there is something in the form of velocity of point B. Okay, velocity of point B is along x-axis. Velocity point B is it's fixed. It's in the sense it's constrained to move along x-axis. Point A is constrained to move along y-axis. Okay. Now, if you fix your attention on the link AB, at this time, the link AB is subtending some angle with respect to x-axis, which is given to us, which is 45-degree angle. Okay. But as this point A moves down, okay, and this point B moves forward, now you will be having the link AB will be like this. Okay, so now look at the angle between A and B is now decreasing. Okay, so as far as the link AB is concerned, link AB is at this instant subtending an angle of 45-degree with x-axis, but as the point A is moving downwards and point B is moving forward, the angle that AB subtends with the x-axis is decreasing. Okay, so this decrease is happening over some period of time, that at time t1 the angle is 45, at time t2 the angle is less than 45, and the angle keeps on decreasing as the time keeps on increasing. So that's why the link AB is having angular velocity omega. Now again, as far as velocity of point B is concerned, the velocity of point B is constrained to move along x-axis, so we say vb is VB is along x-axis, so we write this as VB I cap. We don't know its magnitude is equal to VA. As far as the velocity of point A is concerned, it is given to us it's 2 meters per second, but this is along negative y-axis, so we write this as it's minus 2 meters per second and it's minus 2 j cap. Okay, is equal to, we don't know, plus we have no concept, we don't know what is the angular velocity of the rod AB, so we'll write this as plus omega, angular velocity of the rod, which is not known to us, cross RAB. As far as this RAB is concerned, now we have to write this RAB. We can write this RAB as, we have to draw the radius vector from A to B. Okay, this RAB vector we can write as, once we draw the radius vector from A to B, this RAB vector can be now resolved. Now we know that this is our, this happens to be our y-axis, this is our y-axis, and this is our x-axis, like this. Therefore this RAB can be resolved. Okay, this angle is given to us, this angle is 45 degree, therefore this will be, this component of RAB will be, this component of RAB will be, this component will be, it will be having this as one of its component, and another component will be like this. Okay, these are the components of RAB, and this component of RAB will be RAB cos of 45, cos of 45, and this component will be RA sine 45, and this component is RAB sine of 45. Okay, so this is RAB sine of 45 degree. And as far as the magnitude of RAB is concerned, the magnitude of RAB is given to us. The magnitude of RAB is equal to 0.2. So we can write this as, this is 0.2 cos of 45, and the another component is 0.2. This component is 0.2 sine of 45. These are the two components. Okay, so this RAB here we can write as, RAB can be written as, RAB is having two components. One component is along x-axis, so we write this as, that component is 0.2 sine of 45, 0.2 sine of 45, 0.2 sine of 45 I cap, and its another component is along negative y-axis, that can be written as minus 0.2 cos of 45 along j cap, that is minus 0.2 cos of 45 j cap. Okay, so this is how it goes, minus 0.2 cos of 45 j cap. These are the two components. Okay, now as far as again like we did in the previous question, our VB I cap is equal to minus 2j. Look at the angular velocity vector plus. As far as the angular velocity vector is concerned, we have to see in which direction is the rod AB rotating. every time as the point A is going down and point B is going forward, what is happening to this angle? The angle initially at this instant, at the given instant, the angle is 45. As the time increases, the angle keeps on decreasing. Point A is going down, point B is going forward. So it means the decrease in angle is happening in this direction. Okay, curl your fingers in this direction. The thumb will come out. The direction of the thumb will give us the direction of the angular velocity. And you see, if you curl your fingers in this direction, the direction of the thumb will be along z-axis. So we can write this as, we have omega along k cap, angular velocity is along z-axis. Cross, we have to take the cross product. Its cross product is with 0.2. Sine of 45 is 1 by under root 2, so it is 0.2 sine 45 I cap minus 0.2 cos 45 is again under root 2, that is 0.2 cos I j cap. Okay, this is how it goes. That's equal to, then we can write this VBI cap. This VBI cap comes out equal this minus 2j cap. This is k cross I. Again, we put the vectors. We have I cap, we have a vector j cap, we have k cap. We have the vector k cross I. As far as k cross I is concerned, that's equal to g. So it will be plus omega, angular velocity magnitude, multiplied by 0.2 divided by under root 2, and our k cross I is equal to j cap. We write this as j cap. Then we have again the second component will be k cross j. As far as k cross j is concerned, we are coming in a cyclic order. It will be minus I. That minus will become here plus. So it will be plus omega into 0.2 omega into 0.2 divided by under root 2 I cap. Okay. So we can solve it further. So we can, this is minus 2 j cap and this is I cap. Okay. Now we know two vectors are same when their corresponding components are same. Therefore, as we balance the components, we have first we don't have a j component on the left hand side. Therefore, the components of j, the j components on the right hand side should be equal to 0. So how we will write it? Then as we balance the components, we have minus 2. As we balance the j components, minus 2 plus omega into 0.2 divided by under root 2 is equal to 0. Therefore, from this we will get the value of omega. Omega will be equal to multiplied by under root 2 divided by 0.2. So this is the value of our omega, and this value, this we write as, this is radians per second. Okay, so this is our radian per second. This is the value of our omega. Now, as far as the value of this V is concerned, balancing the components of I components, so we can write, as far as VB is concerned, now VB can be written as I components to balance. VB will become equal omega. Omega, we know omega is 2 multiplied by 0.2 multiplied by under root 2 divided by 0.2. This is our omega, multiplied by 0.2 divided by under root 2. Okay, under root cancel, 0.2 cancels, VB becomes equal to 2 meter per second. Okay, so this is the value of VB. So VB value is also given here, it's 2 meter per second. So we have calculated the value of velocity of point V. This is how we can solve the rest of the questions. Now look at this section, unsolved section. It says set up the relative velocity equation between points A and B, between points A and B, and between points A and B. The question says set up relative velocity equation. We just have to set up, we don't have to solve the problem. Okay, we have to only set up the velocity equations. What we mean by setting up the velocity equations, we have to write the equations only. We don't have to write the what we call as, we don't have to solve the equations. So as far as point AB is concerned, look into the problem A. As far as AB link is concerned, we have to write the velocity of point B in terms of the velocity of point A. So directly, let's suppose this is our origin. Okay, and we start drawing our vectors. Let's call this as our x-axis. Let's say this is our x-axis, and let's treat this to be our y-axis. Okay, so after choosing our x and y axis, this point is our origin, point O. As far as point O is concerned, you look at point O. Point O is the O point, which belongs to this bracket, okay, and the bracket is fixed. The point O does not move. The point O neither moves forward, neither goes up, nor goes down. So first of all, what we will do, we will write the velocity of point A in terms of the velocity of point O. That is, we can write velocity of A is equal to velocity of O plus angular velocity of OA. That is, we write angular velocity of OA, angular velocity of OA cross the radius vector from O to A. We'll write ROA, ROA. This is the velocity of A. Now, as far as the velocity of O is concerned, O is at rest. O neither moves along x-axis. This is a translational velocity of point O. O does not have a translational velocity. Therefore, velocity of O is 0. We'll get velocity of A is equal to angular velocity of OA. As far as angular velocity of OA is concerned, that is given to us, that is 6 radians per second. Now curl your fingers in the direction of this arrow. Okay, the arrow is given to us, it is clockwise. If you curl your fingers in clockwise direction, your thumb will go inside. Okay, thumb will be in this direction. We are treating this our x-axis, we are treating this our y-axis, and we are treating this to be our z-axis. Okay, when you see this angular velocity, the magnitude of angular velocity is 6 radian per second in this direction. If you curl your fingers in this direction, the thumb will come along the minus z direction. So we say, as far as the angular velocity vector is concerned, it is minus 6 radian per second. It is minus 6k cap. Okay, it's along negative z-axis. Cross product with ROA. As far as the ROA vector is concerned, this vector is having magnitude of 3 meter, and this vector is along x-axis. So we write this as 3I cap. Okay, therefore VA will come out equal, we have k cross I, we have I, we have J, and we have K. Okay, we are writing k cross I. As far as k cross I is concerned, we are coming in cyclic order. K cross I will be equal to plus J cap. So it is 6 into 3 is, it will be minus 18. K cross I is J cap. Okay, so as far as the velocity of point A is concerned, the velocity of point A is equal to, the velocity of point A is minus 18 J cap. Okay, now the question says set up the velocity equation between points A and B. We have to set up the velocity equation between points A and B. So what velocity equation we can write between points A and B is very easy for us. Now we can draw the vectors from point O to point A. We can draw the velocity vector, we can draw one more vector from point A to point B, and we can draw one more vector from point O to point B. Therefore, since we are drawing the vector from A to B, we can directly write this as velocity of point B is equal to velocity of point A. We can write the velocity of point B in terms of the velocity of point A. We can write this as, we can therefore write, since we are drawing the vector from A to B, we can write this as velocity of B is equal to velocity of point A, velocity of B is equal to velocity of point A plus angular velocity of the vector drawn from A to B. Okay, that is omega AB, and cross product with the RAB. Okay, you can write this as RAB vector. Okay, this is fine. Now we can write, we know velocity of A. As far as velocity of A is concerned, it is minus 18I. Angular velocity AB, we don't know. We can find out, as we have been finding out the previous angular velocities in previous questions. As far as this RAB is concerned, this RAB vector you can resolve. Okay, now this is angle 60, therefore this angle has to be 60 as well. These are corresponding angles. Therefore you can resolve this RAB into two components. It will have one component in this direction, okay, and it will have another component in this direction. Fine. So this component, you can write this as, this is RAB. RAB is 2 meters, so it is 2 cos of 60, and this component will be 2 sine of 60. 2 cos of 60 degree and 2 sine of 60 degree, and this cos of 60 degree is along minus x-axis, and this 2 cos of 2 sine of 60 is along minus j. Therefore you can write this as minus 18j. VA is equal to minus 18j plus angular velocity of AB. We'll write this as omega AB vector cross RAB vector. RAB vector you can write as minus 2 cos 60 minus 2 cos 60 I cap minus 2 cos 60 I cap minus, you can write this as minus 2 cos 60 I cap, and the other component is minus 2 sine 60 j cap, minus 2 sine 60 j cap. Okay, then you can solve this question in the same way as the previous question. Now look at the velocity of point B. As far as the point B velocity is concerned, we have to set up the equation only. Okay, setting up equation means we have to write this much only. But if some students are interested in solving the question, they can solve it. Look at point B. As far as point B is concerned, the point B will translate either in this direction or point B will translate in this direction. The translation of point B will be along y-axis only. This point B is constrained to translate along y-axis. Let's suppose this point B as this rod OA, as this rod moves down, as this rod moves downwards, okay, it's moving clockwise, it's rotating clockwise, therefore this rod goes down. It will push the rod AB downwards as far as the slider B will move down. That is, velocity of point B will be along negative j cap. We'll write this as VB negative of j cap. Okay, this is the velocity equation between, this is how we have to write the velocity equation, and if you want, you can even solve this equation to obtain the value of VB. Okay, this is how you have to set up the velocity relations. Similarly, we have to set up the velocity relationship between point A and point B. First of all, find the relationship of point A with respect to the point O. Okay, then set up the velocity relationship between point B and point A. Okay, in the same way, or okay, this way you have to do these types of questions. Okay, so I hope you can solve as many as of these. You can write the velocity equation between these questions as much as you can. Now let's go into some other sections. Let's go into this section wherein we try to solve a few more questions. As far as this type of question is concerned, this type of question we have been solving. This is the same question as the question of the ladder we solved last time, because point B will be going downwards, point A will be moving like this. We are here given the velocity of point A, we have to find the velocity of point B. Rest all the parameters are given to you. The way we have solved the ladder question, in the same way I request students to solve this question. Okay, this I am leaving to students because this question is now easy. In the same way, let me solve this question for the students, and I hope then rest of the questions the students can do themselves. Now let's try to solve one more fundamental problem. We have, if the crank, as far as we are given a link, the link OA is called a crank. Crank is a link which undergoes whose motion is complete rotational motion. Complete rotational motion is which it describes an angle of 360 degree. That's called crank. Crank OA rotates with an angular velocity of 12 radians per second. We have crank OA, and this crank OA is rotating in anti-clockwise sense. Okay, and it's rotating in with an angular velocity of 12 radians per second. It says determine the velocity of point B. We have to find the velocity of point B and the angular velocity of the rod AB. We have to find the velocity of piston B, and we have to find the angular velocity of the rod AB at the instant shown. At this instant shown, we have to find what is the velocity of point B and what is the angular velocity of the rod AB. So first of all, let me comment about the velocity of point B. Look, as far as the crank OA is concerned, look into the motion of the crank OA. At this instant, at the instant given, the crank OA is, the vector from O to A is like this. But as the crank rotates with an angular velocity of 12 radian per second in anti-clockwise sense, so it means after some instant of time, this vector OA will move here, okay? And after some instant of time, this vector will be here, OA vector will be here, because rotation is clockwise. So as the vector as the vector is initially, the vector at this instant given to us, the vector OA is like this, but after some time point A will move from this position to this position. Okay, at that time, as far as the vector AB is concerned, the vector AB will be vector from A to B will be like this. Okay, this will be the vector from A to B. But what will happen, what will happen as this A is moving anti-clockwise to its new position, it will pull the link. The link AB will also be pulled, as a result of which this slider B will move up. Okay, the slider B will not be at its position after some instant of time. This slider B will come here. Okay, as you move this forward, the slider will slip, it will move upwards. So the new vector for us will be from point A to point B will be here. Again, after some instant of time, point A is here, point B will be somewhere here. If you draw the vector, it will be somewhat like this. So every time what is happening, as far as the point B is concerned, the motion of the point B will be along y-axis. The point B is moving along, translating along y-axis. Okay. Now, as far as point AOA is concerned, OA is a rod which is rotating anti-clockwise. If you curl your fingers in the direction of this anti-clockwise, the thumb will come along z-axis. So we say the rotation, the sense of rotation for the link OA is along z-axis, or we say it's along k cap. We will set up the velocity relations as we have been doing. That is, first of all, we have to find the velocity. We have to find the velocity of point B. Okay, so what we can do, we can simply, let's treat this to be our origin, as we have done in the previous question. This is our origin. We draw the vector from O to B, we draw the vector from O to A, and we draw our vector from A to B. So we write the equation for velocity will be, velocity of point B is equal to velocity of point A plus angular velocity of AB. We are drawing vector from A to B, therefore it's angular velocity of AB, which we have to find. Angular velocity of AB, angular velocity of the rod AB, cross the radius vector from A to B, that is RAB vector. This is our equation 1. Okay, this will be our equation. Now in this equation, we don't know the value of VA. As far as VA is concerned, VA is the velocity of point A. So what we do, we will find the velocity of point A in terms of the velocity of point O. Okay, so we draw the vector from O to A. So O will serve two purposes for us. Okay, O is the on the rod OA, O is a point of a rigid body, A is a point of the rigid body, as well as O is our origin. So we can write the velocity of A in terms of velocity of O. We can write velocity of A is equal to velocity of O plus angular velocity of OA, that is omega OA cross product with the radius from O to A, that is ROA. Look at this equation. In this equation, we know the value of omega, we know the value of R, we know the value of VO. As far as VO is concerned, velocity of point O is concerned, O is neither moving along x-axis nor it's moving along y-axis. Therefore, we say velocity of point O is equal 0. Therefore, we write velocity of point A is equal to omega OA. It's equal to omega OA cross ROA. Okay. So do we know the value of omega OA? Yes, we know the value of omega OA. That is equal to, the value of omega OA is, it's 12 radians per second. It is 12. And what is the sense of its rotation? If you curl your fingers, your thumb will come along z-axis. So it's 12 k cap cross ROA. The magnitude is 0.3. The ROA vector has a magnitude of 0.3, and it's along y-axis. So we write this as j cap. So that is equal to 12 into 0.3 is 3.6. As far as the k cross j is concerned, this is your I cap, this is your j cap, and this is our k cap. As far as the k cross j is concerned, the k cross j is a cyclic order, that will be equal to minus I. So it is minus 3.6 meter per second, but along I cap. So it is minus 3.6 I cap. We will write the value of velocity of point A. So velocity of point A is how much? Minus 3.6 meter per second I cap. That is, A is trying to move, A is trying to translate along x-axis, negative x-axis, with a magnitude of 3.6. Substitute the value of 3.6 meter per second in this equation, okay, and we obtain the velocity of point B. Let me give a pause here and join the second class where I will be solving this question fully. Thank you very much.